Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about solving quadratic equations by completing the square.
Minute Math, when you need help you use Minute Math.
We're given this problem right here, p squared plus 14p minus 38 equals 0, and we need to solve this by completing the square. So the tricky thing here is we want to really bring this c value over to the right-hand side. So we have p squared plus 14p is now equal to, well, let's give some space here, equal to a positive 38. Now we're going to look at that b value, 14. We're going to use our formula. So we take 1/2 times that 14, see, and then we square that. Well, 1/2 times 14 is 7, so we have 7 squared, and that's 49. So now what we want to do is take that 49, and we're going to add it to both sides of the equation. And what does this make for us? Well, the left-hand side now becomes a perfect squared. P plus 7 squared, and that's equal to, well, 38 plus 49 being 87. So now we have to, well, solve for p. We take the square root of both sides here, and we have p plus 7 equals a plus or minus the square root of 87. Subtract the 7 to both sides, and we have a p is equal to negative 7 plus or minus the square root of 87. And, well, we can write this as two statements. P equals the plus and minus, right? So we can write each one individually. Negative 7 plus the square root of 87, and negative 7 minus the square root of 87. And that's actually our final answer. We're given this problem right here. V squared plus 6v minus 59 equals 0, and we need to solve this by completing the square. First thing I want to do is I want to bring this 59 to the right-hand side. So we have v squared plus 6v, I'm going to leave some space, equals a positive 59. Now I want to take my b value, which is 6. I'm going to use my formula. 1/2 times 6 squared. 1/2 times 6 gives me a 3. And 3 squared is, well, 9. So we're going to take that 9 now and add it to both sides of the equation. The left-hand side becomes a perfect square now. V plus 3 all squared. Right-hand side, well, 59 plus 9 is a 68. Then from here, we want to solve for v. We take the square root of both sides, and we have v plus 3 equals square root over the equal sign, plus or minus the square root of 68. Keep going. We can subtract a 3 to both sides, so v equals a negative 3 plus or minus, and the square root of 68 simplifies to be 2 square root of 17. So now we have our answer really in plus or minus form here with the square root form. So we can write them individually, and v equals a negative 3 plus 2 square root of 17, and v equals a negative 3 minus 2 square root of 17, and that is our final answer. We're given this problem right here, a squared plus 14a minus 51 equals 0, and we need to solve this by completing the square. First thing I want to do is I'm going to bring a 51 over to the right-hand side. So I have an a squared plus 14a, I'm going to leave some space here, equals a positive 51. Now I'm going to look at my b value, which is 14. I'm using my formula. 1/2 times 14 squared. And 1/2 times 14 is 7, and 7 squared is 49. I'm now going to add that 49 to both sides of the equation. Plus 49 and plus 49. Now from here, the left-hand side is a perfect square. That's going to be a plus 7 all squared. Right-hand side, 51 plus 49 is 100. So now we want to solve for a. We take the square root of both sides, eliminates the squared on the left. We have an a plus 7 on the left. Square root of 100 is easy, it's 10, but we can't forget our plus and minus. So now we subtract a 7 on both sides, and we have a equals a negative 7 plus or minus 10. So let's do each one individually, right? Well, negative 7 plus 10, a positive 10, right? Negative 7 plus 10 is a positive 3, and negative 7 minus a 10 is a negative 17. And so our two answers are a equals 3 and negative 17. We're given this video problem right here. X squared minus 12x plus 11 equals 0, and we need to solve it. Well, I want to first subtract 11 to both sides. I have x squared now minus 12x equals a negative 11. And notice I left a space here, and you'll see why in a minute. My b value is negative 12, so I use my formula. 1/2 times a negative 12 squared. Well, 1/2 times a negative 12 is a negative 6. Square all that, and we get a positive 36. So now I'm going to take that 36 and I'm going to add it to both sides of the equation. Now the left-hand side is a perfect square. It's x, that's a minus sign, through x here, x minus a 6 all squared equals, well, negative 11 plus 36 is 25. We now need to take the square root of both sides to solve. X minus 6 equals, don't forget the plus or minus, taking the square root over equal sign, and the square root of 25 is just 5. So we add a 6 to both sides, and we have x equals a positive 6 plus or minus 5. So what does that come out to be? Well, 6 plus 5 gives us 11, while 6 minus 5 gives us a 1. And so our two solutions here are x equals 11 and 1. We're given this problem right here. X squared plus 6x plus 8 equals 0, and we need to solve this by completing the square. First thing I'm going to do is I'm going to subtract an 8 to both sides. So we have x squared plus 6x, I'm going to leave myself some space, equals a negative 8. Now I look at my b value, which is 6. I'm going to use my formula. 1/2 times b, which is 6, that's what I get for saying the formula and not actually writing the value. But also, b and 6 kind of look alike. All squared. Well, 1/2 times 6 is 3, and 3 squared is 9. So we're now going to add a 9 to both sides of the equation. Now from here, the left-hand side is a perfect square. X plus 3, all squared. The right-hand side, well, negative 8 plus 9 is 1. Now we want to solve. So I take the square root of both sides here, and we have an x plus 3 is left on the left-hand side. Square root makes it a plus or minus over the equal sign, and the square root of 1 is just 1. So now we subtract a 3 to both sides. We have x equals a negative 3 plus or minus 1. So what are these two solutions? Well, let's go do each one individually. Negative 3 plus 1 is a negative 2. Negative 3 minus 1 is a negative 4. And so our two solutions are x equals a negative 2 and a negative 4. We're given this problem right here. N squared minus 2n minus 3 equals 0. And we want to solve this by completing the square. Well, the first thing I'm going to do is I'm going to add a 3 to both sides. N squared minus 2n equals a positive 3. Now from here, I'm going to look at my b value. And again, notice I put a space here. It's going to be helpful in a moment. My b value is negative 2. So I use my formula. 1/2 times a negative 2, all squared. And negative 2 is, well, 2 over 1. Might make it easier to see. Well, 1/2 times a negative 2 is a negative 1. So we have negative 1 here, squared. Negative 1 squared is a positive 1. So I'm going to add a 1 now to both sides of the equation. The left-hand side is now a perfect square. It's n minus 1, all squared. Right-hand side, 3 plus 1 is 4. Now I can take the square root of both sides, eliminates the squared on the left, n minus 1 is on the left, and on the right, square root causes the plus or minus here. And the square root of 4 is 2. We now have to add a 1 to both sides, and we have n equals a positive 1 plus or minus 2. So what are our solutions? Let's solve each one individually. 1 plus 2 is a 3, and 1 minus a 2 is a negative 1. And so our two answers are n equals 3 and negative 1. We're given this problem right here, x squared plus 14x minus 15 equals 0, and we need to solve this by completing the square. Well, the first thing I want to do is I'm going to add a 15 to both sides. So we have an x squared here plus 14x. I'm going to leave a space equals a positive 15. Now let's look at our b value. We use our formula, 1/2 times 14 all squared. Well, 1/2 times 14 is a 7 squared, and that's 49. So we're going to add a 49 to both sides of the equation. So what do we get? Well, the left-hand side is a perfect square now. The whole point. It's an x plus a 7 all squared. The right-hand side is, well, 15 plus 49 is a 64. We now have to take the square root of both sides of the equations, and we have x plus 7 equals plus or minus, because we took the square root of an equal sign, and the square root of 64 is an 8. We now have to subtract a 7 to both sides, and we have x equals a negative 7 plus or minus 8. So where do we go from here? Well, we can just solve it now. We just solve the plus and the minus solution here. So let's go with the plus. Negative 7 plus an 8 is a positive 1. Negative 7 minus an 8 is a negative 15. And so my final answers are x equals 1 and negative 15. We're given this problem right here. K squared minus 12k plus 23 equals 0. And we need to solve this by completing the square. First thing I want to do is subtract a 23 to both sides of the equation. So we have k squared minus a 12k, and then subtracting the 23 gives me a negative 23 on the right. I'll notice I left space here. It'll be important. Now my b value is negative 12, so I'm going to use my formula. 1/2 times a negative 12, all squared. Well, 1/2 times a negative 12 is a negative 6. We square that and we get a positive 36. We're now going to take that 36 and add it, don't forget, to both sides of the equation. So the left-hand side now is a perfect square. K minus a 6, all squared. The right-hand side, negative 23 plus 36, is a positive 13. To solve this, I now take a square root over the equal sign, and we have k minus 6 equals the square root of 13. Doesn't really simplify. Add a 6, oh, don't forget, it's a plus or minus. Square root over an equal sign, plus or minus. I almost forgot. Add a 6 to both sides, and k equals a positive 6 plus or minus the square root of 13. So how can we write this, well, individually? So k equals, well, 6 plus square root of 13 and 6 minus the square root of 13. These are our two options, and that is our final answer. We're given this problem right here. R squared minus 4r minus 91 equals 7, and we want to solve this by completing the square. Well, the first thing I'm going to do is I'm going to add a 91 to both sides of the equation. So we have r squared minus 4r equals, I'm going to leave a space, and 91 plus 7 is a 98. Now, I look at my b value, negative 4. Let's use our formula. 1/2 times a b, which is a negative 4, squared. Well, 1/2 times negative 4 is a negative 2, squared. That's a positive 4. So we're going to add a 4 now to both sides of the equation. The left-hand side becomes our perfect square. R minus 2 squared. 98 plus 4 is, well, 102. So let's go solve. Square root of both sides here. And we have r minus 2 equals plus or minus. And the square root of 102 doesn't really simplify anymore. So we have 102. Now we add a 2 to both sides. And we have r equals 2 plus or minus the square root of 102. So we can write this actually individually. So the first part, 2 plus square root of 102, and let's show the 2 minus the square root of 102. And that is our final answer. We're given this problem right here. X squared minus 10x plus 26 equals 8, and we need to solve this by completing the square. First step is I'm going to subtract a 26 to both sides of the equation. So we have x squared minus 10x, and I'll leave a space here. And then 8 minus a 26 is a negative 18. Now I look at my b value, which is negative 10. 1/2 here times a negative 10, I'm using my formula, square. Well, 1/2 times a negative 10 is negative 5. And then we square that, and we get a positive 25. So we add now a 25 to both sides of the equation. Well, x squared minus 10x plus 25, that's a perfect square. So we have an x minus 5 here, all square. And negative 18 plus 25 is a positive 7. Now we have to take a square root of both sides. We have an x minus 5 here equals plus or minus, don't forget it, square root of 7. Add a 5 to both sides, and we have x equals a positive 5 plus or minus the square root of 7. And so now we can write this, instead of plus or minus, let's do each one individually. 5 plus the square root of 7, and 5 minus the square root of 7. And so that is our final answer. We're given this problem right here. K squared minus 4k plus 1 equals negative 5, and we need to solve this by completing the square. Well, first thing is I'm going to subtract a 1 to both sides of the equation. So we have k squared minus 4k. I'm going to leave a space, and negative 5 minus 1 is a negative 6. I now look at my b value, which is negative 4. I'm going to use my formula. 1/2 times a negative 4, all square. Well, 1/2 times a negative 4 is a negative 2, and we square that, and we get a positive 4. So now I'm going to add a 4 to both sides of the equation. From here, the left-hand side is a perfect square, k minus 2, all squared. The right-hand side, well, negative 6 plus 4 is a negative 2. I now need to take the square root of both sides, and we have a k minus 2 equals, well, just plus or minus, and the square root of negative 2. Square root of negative 2, that's tricky. Well, square root of negative 2 is the same thing as the square root of negative 1 times the square root of 2. Let's keep that in mind. Add a 2 to both sides, and we have k equals a positive 2 plus or minus, and the square root of negative 1 is I. And that's I times the square root of 2. So now let's go separate this out. We have we have a plus and a minus. So we can write this as k equals 2 plus I square root of 2 and 2 minus I square root of 2. And that is our final answer. We're given this problem right here. B squared plus 2b equals a negative 20. And we want to solve this by completing the square. Well, right now that c value is already on the right-hand side of the equation. So our b value being 2, I'll use my formula. 1/2 times 2, all squared. 1/2 times 2 is 1. 1 squared is 1. So now I'm going to add 1 to both sides of the equation. B squared plus 2b plus 1 equals a negative 20 plus 1. The left-hand side is a perfect square, and that is just b plus 1 all squared. The right-hand side, though, negative 20 plus 1 is a negative 19. We now need to take the square root of both sides of the equation, and we have b plus 1 equals, well, the square root of negative 19, we have to do a plus or minus, we took it over an equal sign. And the square root of negative 19 is the square root of negative 1 times the square root, of 19. Woof. That's sorry, I got it right. Well, square root of negative 1 we know is an I, okay? And so if we subtract a 1 to both sides, we have a negative 1 plus or minus that I times the square root of 19. We now have a plus or minus going on. So let's go deal with each one. Let's write the first one, negative 1 plus I square root of 19, and negative 1 minus I square root of 19, and those are our final answers. We're given this problem right here. V squared minus 6v equals a negative 91. And we need to solve this by completing the square. Well, first thing I see here is we have a b value of negative 6. So I'm going to use my formula, 1/2 times a negative 6 all squared. Well, 1/2 times negative 6 is a negative 3. And then when we square that, we get a 9. So I'm going to take that 9 value and I'm going to add it to both sides of the equation. V squared minus 6v plus 9 equals a negative 91 plus 9. Now the left-hand side is now a perfect square. It becomes v minus 3 all squared, and that's equal to a negative 91 plus 9, a negative 82. So now from here we can take the square root of both sides of the equation, and we have a v minus 3 on the left, plus or minus, don't forget it, and the square root of negative 82, which we can write to be the square root of negative 1 times the square root of a positive 82. Well, what do we know about the square root of negative 1? That's I. So we add a 3 to both sides, and we have v equals a positive 3 plus or minus that I times the square root of 82. And that's pretty much it. We can separate it now. We have a plus or minus. The square root of 82 doesn't simplify anymore. And so we can say that v equals, let's deal with the plus part, 3 plus I square root of 82, and 3 minus I times the square root of 82. And that is our final answer. We're given this problem right here. N squared equals 18n plus 40. And we need to solve this by completing the square. First thing I'm going to do is I'm going to take my b value, or 18n, and I'm going to subtract it and put it to the left-hand side. So in doing that, I have an n squared minus an 18n. I'm going to leave a space here, and then we just have a 40 on the right-hand side. Now my b value is negative 18. I'm going to use my formula here, 1/2 times a negative 18 all squared. Well, 1/2 times a negative 18 is a negative 9. And then when we square that, we get an 81, and it's positive. So I'm going to take that 81 and I'm going to add it to both sides of the equation. Plus 81 plus 81. Now the left-hand side is a perfect square. N minus 9 all squared. And the right-hand side, well, 40 plus 81 is 121. Take the square root of both sides here. And I have an n minus 9 now is equal to plus or minus, and the square root of 121 is just 11. So now I have to add a 9 to both sides, and I have an n equals a positive 9 plus or minus 11. So what are my two values for n here? Well, we have 9 plus 11, which gives us our 20, and then 9 minus 11, the second one there, is a negative 2. And so my final answer now is just n equals 20 and negative 2. We're given this problem right here. 5k squared equals 60 minus 20k. And we need to solve this by completing the square. Well, first thing I notice is all my coefficients are divisible by 5. So I'm going to divide both sides by 5. And I'm left with a k squared here equals, well, 60 divided by 5 is a 12. And then 20 divided by 5 is a 4, so we have 12 minus 4k. It's just a lot easier to deal with. I'm going to add a 4k to both sides, and I have a k squared plus a 4k, leaving a space here, is equal to 12. Well, I'm going to take now my b value. You'll see why I left a space there in a moment. My b value being 4, and I'm using my formula. 1/2 times 4, all squared. Well, 1/2 times 4 is, well, 2. You square that, and we get 4 again. So I'm now going to actually add a 4 to both sides of the equation. The left-hand side becomes a perfect square. K plus 2, all squared, is equal to, well, 12 plus 4, which is 16. I now have to take a square root of both sides, and we have a k plus 2 here is equal to plus or minus the square root of 16, well, which is 4. Now, we just have to subtract a 2 to both sides, and we have k equals a negative 2 plus or minus 4. And let's now solve each one individually. negative 2 plus 4 is a positive 2. Well, negative 2 minus a 4 is a negative 6. Lots of place there. And so now our final answer here is just k equals 2 and a negative 6. We're given this problem right here, 6x squared minus 48 equals a negative 12x, and we need to solve this by completing the square. I'm going to first add a 12x to both sides and then add a 48 to both sides, bringing the 48 to the right and then 12x to the left. So a 6x squared plus 12x now is equal to a positive 48. Okay? Well, I noticed that the value 6 actually goes into each coefficient here. So I'm going to divide both sides by 6. I'm left with an x squared on the left plus, well, 12 divided by 6 is 2, so we have 2x. I'm going to leave a space here. We'll use that in a moment. And then, well, 48 divided by 6 is just 8. And so we have an 8 right here. All right. Now I'm going to look at my b value. That's 2. I'm using my formula. 1/2 times that 2, all squared. Well, 1/2 times 2 is 1. We square 1 and we get 1 again. So I'm going to add a 1 to both sides of the equation. The left-hand side is now a perfect square of x plus 1, all squared. And the right-hand side, 8 plus 1 is 9. We now take the square root of both sides, and we have an x plus 1 here equals plus or minus, and the square root of 9 is 3. Subtract a 1 to both sides, and x equals a negative 1 plus or minus 3. And now let's go see what our two values are. The plus or minus, we solve each one individually. Negative 1 plus 3 is a positive 2. Well, negative 1 minus a 3 is a negative 4. And so my final answer is just x equals 2 and negative 4. We're given this problem right here. 8x squared plus 16x equals 42. And we need to solve this by completing the square. One thing I notice is each one of these coefficients is divisible by 2. So I'm going to divide both sides by 2. I'm left with a 4x squared plus 8x equals a 21. Now, for completing the square, that was just to simplify it a little bit. But completing the square, when a coefficient, the a value is greater than 1 here, we're going to have to divide everything by that coefficient. So divide this by 4, by 4, by 4, every part here. And so we're left with an x squared plus, well, 8x divided by 4, which is 2x. I'm going to leave a space here. And then 21 over 4 is just a fraction, 21 over 4. We'll leave it as such. I still follow the same process. My b value is 2. So I take 1/2, multiply it by 2, and then I square that. Well, 1/2 times 2 is just 1 squared, and 1 squared is 1. So I'm going to take that 1, I'm going to add it to both sides of the equation. The left-hand side is now a perfect square of x plus 1 all squared. While the right-hand side, 21 over 4 plus 1, is 25 over 4. We now take the square root of both sides. We have x plus 1 here equals a plus or minus. Now, if you remember when taking the square root of a fraction, it's the same as the square root of the numerator and then the square root of the denominator. Square root of 25 is 5, and the square root of 4 is 2. So we have x plus 1 equals, well, plus or minus 5/2. Subtract 1 of both sides, and you have x equals a negative 1 plus or minus 5/2. And what does that come out to be? Well, let's deal with this first one. Negative 1 plus a 5/2 is a 3/2. While negative 1 minus 5/2 is negative 7/2. And so my two solutions are x equals 3/2 and negative 7/2. And that is my final answer. We're given this problem right here. 9n squared plus 79 equals a negative 18n. And we need to solve this by completing the square. First step is I'm going to add an 18n to both sides and subtract a 79 to both sides. So I have a 9n squared. Now we have a positive 18n on the left, and that's equal to a negative 79 on the right. Now, when my a value here is greater than 1, I'm going to take that a value of 9 and divide all parts by 9. Well, the first part becomes an n squared. 18n divided by 9 is just a 2n. That's nice. And, well, negative 79 divided by 9, I just keep the same. Notice I left a space right here. We'll see why in a minute. My b value is 2, so I use my formula now. 1/2 times 2 squared. 1/2 times 2 is 1, and square that, and 1 squared is, well, 1. I take that 1 and I'm going to add it to both sides of the equation. The left-hand side now is a perfect square. And it is an n plus 1, all squared. The right-hand side will simplify, so negative 79 over 9 plus 1 is negative 70 over 9. We now take the square root of both sides, and we have an n plus 1 here equals, well, that's plus or minus, we take the square root, and we know we can take the square root of the numerator and denominator individually. Square root of 9, the denominator is just a 3, and the square root, well, of negative 70 is the same as the square root of negative 1 times the square root of 70. Keep going, we can subtract a 1 to both sides. We have n equals a negative 1 plus or minus here. Now the square root of negative 1 we know is I, so we have I square root of 70 over 3. Keep going, let's put it up here. I want to combine these into one fraction. So we have n equals, well, this negative 1 is a 3 over 3, so I can have it, let's say, as a negative 3 over 3 plus or minus I square root 70 over 3. We can combine that to be one big fraction of a negative 3 plus or minus I square root 70 all over 3. And so that's really our final answer here. We can write it individually, the plus or minus separately. So we negative 3 plus I square root 70 as one answer over 3. And the second answer would be negative 3 minus I square root 70 over 3. But those two are now our final answer. We're given this problem right here. 2a squared equals a negative 6 plus 8a. And we need to solve this by completing the square. First thing I'm going to do is I'm going to bring the 8a over to the left. So you have 2a squared minus an 8a, and that's equal to just that negative 6. Now luckily my coefficient here of 2, right, I can see goes into each part. So I'm going to divide all parts now by 2, because I want the first coefficient to be a, or to be 1. So we have an a squared here, minus 8a divided by 4, or 2 is 4, minus 4a. I'm going to leave a space here, equals, and negative 6 divided by 2 is negative 3. I now look at my b value, which is negative 4. I use my formula, 1/2 times a negative 4, all squared. Well, 1/2 times a negative 4 is a negative 2. We square that, and we get a positive 4 here. So I'm going to take that 4, and I'm going to add it to both sides of the equation. The left-hand side now is a perfect square. A minus 2 squared. And the right-hand side, well, negative 3 plus 4 is a positive 1. I now can square root both sides, and I have an a minus 2 here is equal to, well, plus or minus, we take a square root over an equal sign, and square root of 1 is just 1. Add a 2 to both sides, and I have a equals a positive 2 plus or minus 1. And so we have to solve now each part individually. 2 plus 1 is a 3. And 2 minus 1 is a 1. And so our final answer here is just a equals 3 and 1. We're given this problem right here. 2x squared minus 5x plus 67 equals 0. And we need to solve this by completing the square. The first thing I'm going to do is subtract a 67 to both sides. So I have a 2x squared minus 5x equals a negative 67. Now my coefficient up front, a, is 2. I'm going to divide all parts by 2 now, because of that. So we have an x squared here, minus 5/2 x. I'm going to leave a space, then my equal sign, and then negative 67 over 2. My b value is negative 5/2. So I use my formula, 1/2 times a negative 5/2 squared. Well, 1/2 times negative 5/2 is a negative 5/4. And then we square all of that, and we get a 25, positive 25 over 16. So I'm going to add that 25 over 16 to both sides of the equation. Same process as before, just with fractions, but same rule still applies. The left-hand side is a perfect square of an x minus 5/4 squared. The right-hand side, when added together, comes out to be a negative 511 over 16. We now take the square root of both sides. Again, same process. And we have an x minus a 5/4 here equals plus or minus, well, the square root, square root of negative 511 or 16. We can take the square root of each part individually. And the numerator breaks down to be, well, square root of negative 1 times the square root of 511. The denominator, square root of 16, is just 4. We can add a 5/4 to both sides. So we have x equals a positive 5/4 plus or minus. Now, square root of negative 1 is I times square root of 511 over 4. Let's continue up here. And notice we have the same denominator of 4 and 4. So we can write this as a single statement of 5 plus or minus I square root of 511, which doesn't simplify anymore, over 4. Now, that plus or minus really is two different numbers, so if we write that out, we have 5 plus I square root of 511 over 4, and 5 minus I square root of 511 over 4, and that is our final answer. We're given this problem right here, 4n squared plus 4n plus 36 equals 0, and we need to solve this by completing the square. First thing I notice is, why don't we divide both sides by 4, that a value. So I do that, and I'm left with an n squared plus, well, n plus 9 equals 0. I'm going to subtract the 9 to both sides, and we have an n squared plus n, I'm going to leave a space, equals a negative 9. My b value, what's right in front of this n, is 1. So I use my formula, 1/2 times 1 squared. 1/2 times 1 is 1/2. Square that, and we get a 1/4. So now I'm going to add a 1/4 to both sides of the equation. Plus 1/4 plus 1/4. The left-hand side is a perfect square, n squared. Well, it's not n squared, but that being a perfect square, we have a n plus a 1/2 here, all squared. And the right-hand side, well, negative 9 plus 1/4 is a negative 35/4. We take the square root of both sides, and we have an n plus 1/2 here is equal to, now it's plus or minus here, and square roots of fractions, we can do the numerator and denominator individually. The numerator, square root of negative 35, is the same thing as the square root of negative 1 times the square root of 35. The denominator, square root of 4, is 2. So now, let's subtract 1/2 to both sides, so n equals a negative 1/2. Then we have plus or minus here, and the square root of negative 1 is I. So we have I, square root of 35 over 2. Let's keep on going here, and n equals, and notice we have the same denominator, common base of 2. So we can add them together, so we can write it as a negative 1, plus or minus I square root of 35 over 2. Now, this is a single statement showing two numbers. If we wanted to show it separately, we'd do the plus and then the minus. So we have negative 1 plus I square root of 35 over 2. And I'll show the minus now. Negative 1 minus I square root of 35 over 2. And these two are our final answers. We're given this problem right here, 7k squared minus 16k plus 100 equals 0, and we need to solve this by completing the square. I have an a value of 7. I'm going to divide that 7 to all parts, or really both sides of the equation. Coming down, we have just a k squared here, minus, well, 16/7 k, plus 100 sevenths, and that equals 0. Not pretty. Same process still applies though. Don't be afraid of the fractions. Subtract 100 over 7 to both sides. So we have k squared minus 16/7 k equals, I left a space there, negative 100 over 7. Now my b value is negative 16 over 7. So use my formula, 1/2 times a negative 16 over 7 squared. Well, 1/2 times negative 16 over 7, okay, and squared comes out to be a 64 over 49, okay? So I'm going to take that 64 over 49 and I'm going to add it to both sides of the equation, plus 64 over 49. Now the left-hand side is a perfect square. That is the k minus 8/7 squared. And that 8/7 is what 1/2 times negative 16/7 is, that negative 8/7 here squared, just so you can kind of see that. And then that gets us to 64 over 49. And that's equal to, adding the right-hand side, comes a pretty big fraction, negative 636 over 49. I now have to take the square root of both sides of the equation, and I'm left with a k minus 8/7 here equals a plus or minus, and the square root of negative 636 over 49. Well, if it's a fraction, we can take the square root of the numerator and denominator individually. So the numerator, square root of negative 636, is the square root of a negative 1 times the square root of 636 over the square root of 49, which is 7. We added 8/7 to both sides, so we have k equals a positive 8/7 plus or minus square root of negative 1 as an I, and the square root of 636 comes out to be a 2, so those times 2, square root of 159 over 7. So let's make this a little neater. We have k equals, notice we have a 7 in the denominator for both parts, so we can combine it to be one fraction over 7. And we have 8 plus or minus. Proper technique or writing would have the 2 first, then the I, and the square root of 159. Now, this represents two numbers, so we can write them individually as k equals an 8 plus, by itself, 2i, square root of 159 over 7, and then 8 minus 2 square root of I times the square root of 159 over 7, and these two are our final answers. We're given this problem right here, 10p squared plus 4p plus 77 equals 9, and we need to solve this by completing the square. My coefficient is 10, so for the a value. So I'm going to divide both sides of this equation by 10. And I get a p squared plus, well, 4p divided by 10 is a 2/5 p plus 77 over 10 equals, well, 9/10. Now I'm going to subtract a 77 over 10 to both sides, and that simplifies and comes out to be, well, p squared plus 2/5 p. I'm going to leave a space, and 9/10 minus 77/10 comes out to be a simplified negative 34 over 5. Alright, now my b value here is 2/5. So I'm going to take that 2/5 and use my formula. 1/2 times 2/5 squared. 1/2 times 2/5 is really a 1/5 squared, which is, well, 1 over 25. So I take 1 over 25 and I'm going to add it to both sides of the equation. The left-hand side now is a perfect square of p plus 1/5, all squared. And the right-hand side adds up to be a negative 169 over 25. I now can take the square root of both sides of the equation, and I have p plus 1/5 is equal to plus or minus, and we have to, well, break up the square root here. We know the square root of a fraction can take the square root of the numerator and denominator individually. So negative 169 would be the square root of negative 1 times the square root of 169 over, well, square root of 25, which is 5. We can subtract a 1/5 to both sides, so we have p equals a negative 1/5, plus or minus. Square root of negative 1 is an I, and the square root of 169 is 13 over 5. Well, we can combine this now with a single statement. We have the same denominator as 5, so we can write it all over 5 here. And we have a negative 1 plus or minus here, and usually write the 13 first, so we have 13i all over 5. Now this represents two different numbers. Those numbers are if we add or subtract, hence the plus or minus. So we have a negative 1 plus 13i over 5 as a number, and negative 1 minus 13i over 5 as another number, and that is our final answer. We're given this problem right here. 3x squared equals a negative 4 plus 8x, and we need to solve this by completing the square. First thing I'm going to do is I'm going to bring the 8x over to the left. So we have 3x squared minus 8x equals a negative 4. Now my a value is a 3, and we want that to be a 1. So I'm going to divide both sides of the equation by 3. Left-hand side is just an x squared minus 8/3 x. I'm going to leave a space here, equals a negative 4/3. My b value now is negative 8/3. So I use my formula, 1/2 times a negative 8/3, all squared. Well, 1/2 times negative 8/3 is a negative 4/3 squared, which comes out to be a positive 16 over 9. So I'll take that 16 over 9 and add it to both sides of the equation. In doing so, the left-hand side becomes a perfect square. X minus 4/3 squared equals, well, negative 4/3 plus 16/9 comes out to be a 4/9. We take the square root of both sides here. Same process as before. X minus 4/3 equals plus or minus. And the square root of 4/9, well, we can take the square root of the top numerator and denominator individually. Square root of 4 is 2, and square root of 9 is 3. Add a 4/3 of both sides. We have x equals a positive 4/3 plus or minus 2/3. And now we can write them by solving each the addition and then the subtraction. So 4/3 plus a 2/3 comes out to be a positive 2, while 4/3 minus 2/3 comes out to be a 2/3. And so my final answer is just x equals 2 and x equals 2/3. I hope this video was helpful for you, and if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you, for everyone else. So as always, thanks for watching.
Minute Math, when you need help you use Minute Math.